where there's this many of you that you're signed up for round 2 in this case. You picked a good one though. We only get to do this once. I'm filling in essentially, so this will be a good, cool experience. Hopefully, I'm trying a few things that I don't know. It's kind of just going to be a one-off on things. It's going to be good, but anyway, this is my thing. I'm excited to say the least. I'll try and slow down, speed up. I don't know, whatever you guys tell me. Just you know me enough. It's okay. And speaking of, we don't have time for it today, but man, I made a lot more videos and crazy crap. So we're gonna, we got dogs to meet, we got like all kinds of stuff. Don't worry. It's been a busy summer. Come on. Can't spoil the memes yet. It's got a bad delay in this room though. Hurry up, come on. There we go. We're working on it, don't worry. It was better than genetics yesterday. We got no audio in the room, so something had to go bad. Regardless, you might be a little familiar with some stuff, but you know, I gotta send everybody out. Like I said, this is horrible. It was May, like 2 weeks ago. All the adventures I had, shoot, mostly just walking the dogs, but you know, what are you gonna do? And again, y'all are pretty familiar with this, most of you, but again, maybe I've changed and grown. I got tenure, I got crazier, so that's good. I think we'll be okay. Regardless, I'm not gonna talk about the slides, but yeah, teaching philosophy, you know, resilience, story, intrigue, that's what we can do here. We have a special chance, especially in this class, because this is one of those culmination style biology classes where everything comes together. This, immunology, some of the big ecology style stuff. There's not every day that will basically fit it all in one. I told you all before that, you know, genetics was the one that I was like, when I was at Carleton, I was like, I want to do what that guy's doing. And that's true. But this is different. I'm not a pure geneticist. This is what I do. And I'm hopeful that I can transfer some of that kind of over. It's going to be exciting. And I will fail this. It's not possible to always be the best course you've ever taken, but that is always the goal. Whatever I do, even no matter how evil it may feel, promise, I have goals and ideas in mind. So again, you all know me though. Tread carefully. You do have to show up and do stuff and know stuff. There will be exams. Speaking of, like I said, we are pretty safe on the final exam craziness, right? Wednesday, full 2.5 hours. Good. But we'll see how that goes. Anyway, I can't win, you win. And I've made the fun idea. I wouldn't schedule you up against the final exam where it's like, what does a tumor cell do? Question, worth 100 points, mitosis. Come on, we're big dogs. Yeah, most of you are gonna graduate in a bit here. So we're gonna make this big, but it's gonna be supportive too. I'm here. And trust me, I'm gonna get tired of the genetic students. So please find me for office hours. I need help. Okay. This was there to scare them today. There was some oohs and ahs in genetics. It was there. This was some of you all right there, right? Yeah. High attendance over 90, looking good. Ouch. Bad idea. Sarah, stop it. Be a good example. You don't need to over-visit office and open hours, especially for a broader class like this. Like I'm obviously available on like quick email type stuff, but again, I mean, this is a big discussion style, story, history, spanning type of thing. Like we'll start in the beginning and we'll go to the end as far as we can go, and we'll hope look into the future. Some of that takes time to discuss, me as groups, things like that. Yeah, you guys remember this. You guys remember this from genetics a little bit. You're supposed to say, all right, like here's all this good stuff. There's me, I'm sad. There are weaknesses. Only childs even have them. All right, how real do you think this was after having me in a couple of classes? Extroverted, that's fair. Kind of numbery. Type A? More type B. I don't know. It's in there somewhere. There's a couple good ones. I don't know. I don't think I quite stuck the landing in genetics. I think they mainly just emphasized this when I was on this slide. I'll be okay, it's fine. But at the same time, this is a 400 level class. There are higher expectations than a 200, 300, theoretically. Oh, look, and I took another one because I'm doing the honors class now. Look at my little top strengths. Remember, each one's weakness. That's the kind of neat thing about tumors as well. I'm not calling myself cancer, but any strength you do, you'll see is a weakness. Learner, that's great, hooray. Spend too much time not doing things. Look at the two that are in conflict as well. I love harmony, but somehow I'm competitive. It tries to explain it in the thing, and I was like, thank God I didn't pay for this. All right. Most of you know this system too. No, nothing crazy. I will given this is the first time we've done this class, and those of you that have had me in farm bioinformatics and stuff, there's a lot of times that I take test read stuff. When I make the slide, I'm like, yeah, I'm going to test on this. And then I sometimes in class, I'm like, let's tone things down a little bit. That might happen sometimes with the key info. Like you may see something that goes from red to blue. That's to help you. Promise it's not to flummox you or anything else. If you're colorblind, let me know now, not in week 15. Like I said in genetics, but it's different this round. Supernatural like events is how sometimes I describe what we're up against with this. Advances that we've made as well seem impossible, would have seemed impossible 10 years ago. If I told you 15 years ago we could genetically modify a T cell out of a patient, stick it back in, and it's going to kill and hunt cancers, you call me nuts. Call anybody nuts. But I promise, like as I learned about this, it was the blue and the green text type slides that kept me like coming back. It's kind of cemented being a teacher was cool. All right, regardless, yeah, we're in person, we're real class. Employers ask about that now, especially with the exams. Key info, PDFs posted, preview those notes, it'll help. Again, first time leaving class, so things will be in more flux than you're used to if you've had me in genetics. If you had me in farm and the others, you know that things might change a bit. Y'all are mature, we're gonna just leave the recordings, that'd be fine. That's just to scare the genetics students. Everything's free, by the way, so that's good. Don't buy anything. If it says buy it, don't, okay? You're good. $0 spent on textbooks. This one's different. Y'all probably saw grade load today, right? We'll talk about it in specific, but 200 of the 500 points are just gonna be stuff we either do in class. I wouldn't use the word homework. I'm hoping it's a little more project-based. But otherwise, yeah, I'll kind of let you get some details because this would be a bigger change than the classes you probably had me in. Like I said, I only get to do this one time. We'll have certain things that hopefully are more experiential, if you call it. For example, next week we'll talk about cancer surgeries and such. Let's just say that we will be spinning over to the genetics lab quickly and doing something a little more active than listening to me talk. It'll be fun. You're all biomed types. We'll have a great time. Now, here's where those 25 points are. All this is a test of communication, accountability. You don't need to call it professionalism, but it's the main like sticking word I could think of. No. I will not trade Jameson Williams. No. All right. All right. All these are just communicate. That's it. And part of this is just, being normal. That I am, I'm not saying normal, but just saying like, stay on track and stuff. Be all right. Speaking of, the only reason this stuff's in here is most of you are biomed types. When things go wrong, it's because people either make mistakes, don't speak up, all that kind of stuff. We're not in a medical emergency here, but pretty good. All right. Again, you've seen these if you've had me. The basics are always there. Doesn't hurt to try them. Like the bottom one always freaks people out, but that is what the med centers tell the students. They actually say up to 8. This is not a med center. You're not med students, but at the same time, doesn't hurt to try. The class format is also tough. This is your first time having a block class. Like it's different to study for. I learned that with farm. Because it's tough to like start it earlier, like kind of later in the week. Now, hooray, a lot of you know each other already. There's still a big chance to grow your network in the class, hooray. And these are some of the bigger ways to do that. It's not, like I said, it's not a 200 level, so it's not as much, I think it's about the same amount of like pure content as genetics, but we'll see. It'll be a different take on things. But I got my creepy quote at the bottom there because changes that will save you in the end are made now. Don't make them later. You're starting everything now. Oh yeah, and then everybody's favorite, evil. All the bad things, all the rude things you can do. And again, mostly aimed at the sophomores in genetics. Being like, come on, let's get things rolling here a little bit. I'm not too worried here. I think we'll be all right. Nice. And we used to have one that said week study plan, but then it was blank, and that was the joke. Not one of my better ones. All right, anyway. Again, not that you haven't had this 2 or 3 times for most of you, but still, Hooray! My name's Keenan from Colorado. Jumped off that as a kid. It was very naughty. Now it's permitted. Shoot. Sorry. Next, ended up at Carleton College, kind of, what is it, east of here? Small little fun school. Frisbee's overrated. I used to love Frisbee, now I hate it. Omaha, Nebraska. Did my PhD at the Med Center. Omaha, very underrated, by the way, especially if you're looking for grad schools. And the rent isn't like $1 million. Mayo Clinic. Oh, shoot. Speaking of rent. Yeah. Rochester's expensive. That'll be tougher. You two gotta know. Okay. Minnesota State, because I wanted to teach. I like research and I loved it. And I loved what I could do at Mayo. But there was a choosing moment when Gustavus opened a teaching job for, it was a 1-year job. So I kind of bet on myself and we worked out because then COVID happened. So I got it. Regardless, go ahead and say hi to people. I noticed most of you kind of already have a network built around, but do your best. Say hi to summer was, stuff like that. I'm going to pass out some stuff in the meantime.
Are you still? Well, I was talking to him, he's like, yeah, we had this class in 4 hours, and I took a nap. And I was like, oh, I'm gonna take a nap. He's like, it's kind of dangerous. But hell, no danger to him. He's gonna get his 20 points down. I think I'm gonna take 20 of them. I mean, what did that from on the road today? All right, now fill out your little intro cards. I actually enjoy getting to know students, surprisingly, right? Well, that's not meant to be surprising. That's it. All right. 1, 2, 3, and I got something else here too. I got a Sharpie. Amazon sent me wide many cards this year. They are super fun. If your pen doesn't work on these, I'm Sharpie. And it's not super important. 1, 2, 3. Yeah, we're the playing cards there. What's your name on these? You want to pick up? No. Here, what are these? What are these? More getting the card is Ashton's punishment is that he's gonna have like 50 cards in a day. Yeah, sure.
Yeah, I want to do in person.
Zoom recording. We haven't gotten into Greg's text. And that last bit there, this is going to go into a very key concept of this disease. When oncologists, and you can think in the 50s maybe, or 60s, whatever, when oncologists are treating a cancer patient, are they treating the disease or are they treating the symptoms? And obviously it's a loaded question because it depends, right? But how hard would it be to be a healthcare person and know that you're going to lose really bad every time? And that was sort of that dark journey that we were in for hundreds of years. All right, Let's do some red text. But really, it's gonna be pretty familiar. You can sum up this entire class by the friendly mitosis. How many times y'all seen this, huh? At graduation, I hand y'all a piece of paper and be like, draw mitosis. In front of the world, yeah. Be rough. This is part of the process. It is, at its core, the most important hallmark. One must become two, and that must keep happening. We'll see others. We'll see survival. We'll see how it has to avoid the immune system. We'll see that to make that many things, you need a lot of nutrients, right? You're hungry. All these things will come in. But this is the core right here. One becomes two. Same system of life that we've always relied on. Now, a deeper look, but nothing crazy, to 211. Most of your cells are fine right now. They're just rolling right here. Honestly, most of them just stay in G0, right? Just hanging out. Brain cells aren't dividing like this crazy. Your heart cells never divide. That's why there's no heart cancer. Your intestine cells, on the other hand, your skin cells, what's the problem with them? Constantly under attack and dying and making more, right? They have to go through these. We'll see why, like, certain environmental cancers are going to kick these brakes off a little bit. Equally, there are go and stop signals in this. It is an overwhelming amount of go signal that will push towards that M phase eventually. But it's the stops that are more important. The stop genes that you have, every gene that you have that stops something from happening is far more powerful than the ones that stay go. You have to lose those. Who's ever had a mole, right? Grows, stops. Because it just mastered go, go, go. Ran out of steam, died, it didn't survive. Didn't have the other pieces. That's why a sunburn mole is so bad. It starts looking irregular, it starts splintering out, all nasty. It's because it's out of control. It's not getting checked by these things. So, I'm gonna put on here. Stop genes are always more powerful than your go genes. Sorry, I ran out of room there. It's far worse to mutate and lose something protective than it is to gain or amplify something promotional. And there's the other kind of key point, and again, still kind of in 211 territory. Can we drug an overactive oncogene? Yeah, you can toss some chemicals at it, kill it. Beauty of organic chemistry, find a pocket, kill it. Can we bring back to life one of these G2 checkpoint stop genes? Not quite. And the answer 3 years ago would have been a clean no, but we're working. And I say we, like I'm in like me and my like 10 grand startup, like with Mayo and stuff. We is the field, I count myself. All right, getting on that too. Benign, malignant. Benign is like we talked about, mole. All of us in this room likely have had benign tumors grow. But the stops and the natural checks and balances of our body typically stop them. Things need a bigger push to go to the right. The key and the strangest thing is consider yourself, take 5, 6 seconds. How many times you think you've had a tumor cell at least get one mistake that would turn it like this? How many times maybe that is? You can consider yourself as the example or just the typical human if you want. How many people think 1 to 10? And again, we're in hypothesis territory here, so I'll tell you where the hypothesis goes. 1 to 10. All right, 10 to 100. 100 to 1,000 times that you've had a cancerous cell, maybe at least go one thing wrong. 1,000 to 10, 100,000. Let's kick it up there. Okay. You know I'm going to keep going, right? Probably have, even at this moment, 100 cells with at least 1 or 2 mistakes running around. But they don't look bad yet, right? They look like your normal stuff. Your body won't kill your normal cells, right? One hidden step and promote the next 4 that would come later to cause that. Now, before that happens, and why we're not just tumors all the time, is because your immune cells, and like we'll get to the details, but your immune system is magnificent. Nobody in this room had ever encountered COVID before it happened. We all probably got it, and we all made a response. Our body can find cells, even our own, and unmask them. So, we will see that there are only a few steps right here. I need a lot to get to that point. A lot. And sometimes those steps are self-inflicted. Who knows anybody that chews tobacco in their mouth? And I'm not talking about the Zyn packets. I'm talking about the brown. If you ever get a chance and ask them how many those white spots you got on your lips and your gums, some chewers are actually pretty proud of the fact that they have so many and they're not dead yet. Next week, I'm not kidding. Next week we'll see oral cancer surgery. To get at the tumors, guess what you actually have to take off and remove and then put it back on? Yeah. Don't chew tobacco. Okay? Please. Don't smoke either, but man. So, while some cells are far more exposed because of their natural issues, right? The intestine is tough because it is always renewing, right? You're always burning, it's acidic, you eat a lot of crap, and that causes bad issues. Some of these are less susceptible, though. I don't have heart cells up there. But that mitosis step that we just talked about, your heart is the heart you were born with. When you have a heart attack, those cells are dead forever. They're not regenerating, no more mitosis. That's why heart cancer is so rare. You don't do mitosis, done. But all of these rely on signaling. Some are damaged. Some are influenced by the immune system and the environment. Some can become anything. You don't even want to know how complicated bone cells are. It's awesome. Terrifyingly awesome. It's crazy. Blood cells are mine. The reason why lymphomas are the 7th most diagnosed is because when you make an immune response, your white blood cells are mutated by your body to evolve and force evolution to happen in that moment. That's a dangerous game, but it's worth it long term, clearly, because that's how we evolved with it. That's the other key here, too. This brings up our first time that I'm sure everybody in the room has heard and seen. Where's this secret cure for cancer, right? It's because, number one, simple ideas to complicated problems always lead to problems. Okay. We've cured plenty of cancers, by the way. They all have a different type, strengths, weaknesses, all kinds of stuff. We'll see them. And the other stuff, you ever hear conspiracy theory? Think about it, rich people suffer from it. Steve Jobs died from pancreatic cancer, right? Who else rich has died from cancer? Like a bunch of people, right? Like actors, Patrick Swayze. Yeah, there ain't no miracle cure for like pancreatic or some of the other bad ones. And the word cure is always tough because we're very careful about that. We're closing in on that for some of the white blood cell stuff. Like I said, 5 years ago, would have never said that. So, what do you think that tumor was? Sorry, it's a little graphic. You're gonna see some S word in this class. Yeah, it's a little tough right there, huh? Hair, teeth, gums. That came from a stem cell origin tumor. Stem cells can become anything. And the disconnection with science and the public and the law means that, who's ever heard of a stem cell clinic and injections, right? Just make you sign and say, like, whatever happens, you can't sue us. I don't know what half those things are injecting into people, but if you inject stem cells, you got no control over those things. People have grown bone in their face before, teeth in their, I'm not going to say, but I'm not joking. Don't mess with stem cell stuff. This is teratomas. When you got the unlimited, unlocked potential, you could become any cell. The game is over at that point. How can we fight a war that, is on 8 fronts? Let's get out of here. Well, there's more worse things. There we go. I mean, you wanted the real stuff. I know we got a lot of pre-dental people in here because I'm not kidding, man. This is one of the best ways you can prevent people from dying, suffering, and all that bad stuff, okay? And your job is almost a public health thing at the same time. It's not just treatment, it's informing patients of the dangers. Because when the time comes, our cells, the ones we're all in here with right now, they are quite good at what they do. But the tumor cell will outcompete them, it will outeat them, it will push out the immune system, and it will take over. And I mean, we've all seen the lungs. We've all seen, I think that one in the middle is pancreatic. Blows up. Now, as you can tell, we can cure things with surgery. Does that mean that it is a perfect solution at all? You can just be like, of course, it's fine, it's cured. And I say this again, like not being a woman, but having talked to patients, it's like, this is psychologically, this is not good to do. Okay. So just the treatments alone are still so tough. That's what we have to do. So, a little active activity. I talked long enough. Pause the recording. Yeah. It feeds into why things would work. And the key thing that you'll see across all the history treatments and everything like that, we kept just throwing chemicals at everything and not knowing why we were doing anything. You'll see that we, even today as we cover things, we don't know why. We don't get out of the dark ages, okay? So, not ideal. Why didn't we talk about cancer in history before? What was killing us instead? What was killing us before we got older? All kinds of stuff. Mostly remember, used to have a lot of kids because we're probably going to lose about 40% of them on average, no matter what. So pre-1950, what do we got in 1950? We've done a lot better with antibiotics. Done a lot better with public health type stuff, maybe with parasites. Viruses, obviously still a bit of a bane, but the public health side can help. Vaccines are starting at this point and being a little more active, to say the least. Consider what else could have changed in those times. Cancer was always around. It just rare. We live longer now. And ultimately, that's a good thing. Hopefully you guys feel that way. Hopefully you haven't given up on humanity yet. All right, so the one before the Greeks, when we translated the hieroglyphics, there was one medical setup that we had. It was a doctor named Imhotep. He listed 7 conditions, the last of which was tumors. And all he says for treatment, as you can tell, there is nothing to be done. And we see from the mummifications, only the tumors that can survive mummification, right? Yeah, did y'all know that bones can turn into cancer and spread and spine out and make your life hell? They can see as well, though. They did try treatments. Surgical holes. Brain, pelvis, spine in this case. But where's anesthesia on our thing? Tough sledding, to say the least. We get to 1850s. We kind of have anesthesia, even though it's mostly liquor. And a guy sees antiseptics for the first time ever when he sees that sewage is cleaned with carboxylic acid. And he was like, we should clean, I guess, with that before we treat people. Because y'all remember doctors in the old days used to run around with as much blood on their thing as possible to show, like, I'm a big dog, like, had a busy day. And then they'd go deliver another baby, go do smears and stuff. So there's a big reason midwife births back in the day far safer than a hospital. Hospitals used to be like death zones. Doctors were like dirty people, basically. People didn't consider them like good. And back in the day, by the way, surgery was basically like, yeah, you're probably going to die on the table, but that's the way it goes. And that's, I mean, surgery's still dangerous. Don't line up for anything that you don't have to, trust me. I think you caught what was going on in the surgery, by the way. Yeah. Okay. Now, as surgery started to become the thing, chemicals didn't really show up yet. We can just rip it all off. And this was the first mistake that was made for not understanding what this was. Again, we just knew that there were masses. So certain physicians were like, just cut more, just cut more, just cut more. There were a few that could tell when the patient has these sites and these swollen lymph nodes. I think it means that the tumor, whatever this thing is, has escaped, because everyone that we treat and cut off that has a lymph node infection, it comes back. It comes back a lot worse. So why put these people through this horrific surgery? And you can't quite tell, but a true radical mastectomy is going to take your collarbone off as well. Your pec, everything, it's all gone. And so you had a lot of voices just saying, just treat it harder. So this brings us to the beautiful history of cancer eye study, blood cancers. Can't surgery out a blood cancer, right? Can't rip it out, no scalpel. You had to do other things. You had to try stupid things. And this is where you begin. Most of our impressions of cancer in the old days, is it adults or children? Kids a lot, right? Can you imagine a more horrific environment than wards and beds of kids with leukemia in some of the bigger hospitals? And nothing can happen. They're just there for palliative care. That's it. There's a hospice. So it was tough being an oncologist. Who knows the name Farber? Probably maybe heard that a little bit. Farber Cancer Center is Harvard's. You see where this guy's going, probably. And notice that when you didn't have folate in your diet, your blood cells died. This was another consequence of studying public health from World War II. So he was the first one to say, there's no other option. I can take away the folates. I can treat the blood cancer patients, I think. He was a little radical in this case. It wasn't technically, there were no trials at this point. There were no IRBs at this point. He's just doing this. So he finds a molecule that destroys or erases folate. And that was the beginning of chemo. We move on, 20s. Madame Curie, there's even there's a photo of her downstairs. Tons of advances. Everything, all the baseline we know about radiation comes from there. X-rays, all that good stuff. A severe consequence of their exposure is that she died from several diseases, cancers, all kinds of stuff. But the main thing she lived with her whole life, anemia. All her blood cells were dead. All her white blood cells were gone. So Farber's putting some of this together. We can't surgery the blood cells out, but there's these things that hurt it. They cause anemia. Can we repurpose this? Then I can try and summarize where true chemistry is about to show up here in the 50s and meet Farber and give him the idea. Okay, here we go. In the beginning, chemistry, organic, what Dr. Bethel shows you. It was a madman's game. Snake oil salesman, we all heard that, right? You'd sell just jars of whatever on here. The first thing in Germany was the first one to master this, dyes. Much better than finding plants and going them all over the clothes, right? Expensive. Dyes were cheap. Could make them synthetically. And I put up there in the blue, when urea was synthesized, it was a sort of unholy moment for the humanists because they're like, but that's a human chemical. How'd you make that in the lab? That can't be possible. The next thing that was very necessary. Who's ever heard of the Ireland potato blight? Yeah. We solved it, kind of. Can you read that? Yeah. Sprayed arsenic on the potatoes, it worked. Yeah, long-term health issues or Irish habits to be determined later. Okay, no offense to the Irish. So, as the quote says, can't surgery your way out of this. They needed something we could treat with, but this is where chemistry was at in the 30s. We're kind of just running around. Okay, here we go. World War I. Give a quick little thing. This was nasty, okay? Machine guns, but people were charging still, blood, trenches. Germany knew when it started the war, it had to win in the first year or it was going to lose. Same place Einstein was at in World War I time. Max Planck Institute found out use chlorine, kill things, mammals, birds specifically in the lab. It was a big reason why he left. That and the growing anti-Semitism. They needed to win bad. They knew they would lose ultimately. So they made the choice. We're going to synthesize this. And that's all it is. Never mix bleach and vinegar, by the way. I was thinking of doing a controlled version of that for farm, and I was like, I shouldn't commit a war crime the first day. So we don't, I don't know what the word is, appreciate what this was, because we live in an era where the experiment is, if nukes drop, it's over. This was the first time that it could end the world, ideally, is in the eyes of some of these people. The chemical giants were the ones that drive this advantage. It's a big reason why I'm like, we don't have time for the story and how Germany would go to DDT and a couple World War II things in there that I can do, but go. So if you ever see gas, like this will be a hyperlink, we don't have to play it right now. It's terrifying. It's not ideal. It's sorry, I know I'm like joke about grim things sometimes when I'm uncomfortable, but it's tough. This is another reminder, like in the black, like it says, science is just machine. It's math. It's A to B to C, C and D, E. It's process. It doesn't designate right or wrong. I know that's not on the test, but it's something as biology people I want you to recognize. So let's see a quote from a German soldier on the day that they released the gas for the first time on the French lines. Most of the people that felt this were French auxiliaries as well, from India, Africa, all over, but essentially it wiped out the entire frontline army. You want me to podcast this or you want me to read this? Go ahead and read it. All right, thumbs up for podcast. Oh, it's like, go ahead and read. If you can you not read it from there? Or is it fine? Oh yeah, I got it there. Why do we even bother with the projector? Get where we ended up. I'm gonna keep reading. To get where we ended up, though, this had to happen, essentially. There would be no reason to put that many resources in chemistry. Same reasons why the Cold War led to the space advances that we did. We would not have chemo without what you read. At least we wouldn't have the same timeline. So yeah. The Germans actually did not take advantage of this because it was jarring. They had broken the line, which was a rare thing in World War I. But yeah, like the animals screaming, coming out, the hand marks on the throat to rather die than do it. Like, this was also the beginning, think artistically, of what a soldier used to mean before World War I. It was valiant, honor, off to battle, Napoleon, right? Now you're just insects. That's when culture shifted, was the chemicals. Was you are louses and lice to be killed. Fasting. And that's a strange thing with, I don't know, the way history goes. I would have been a history major had it not been biology. But yeah, this was the first time. What was it? This is the first time you could drop something like this on London, and it's like, how many millions of people are going to die or be maimed? Could have been it. So, sneaking around World War II, by the way, chemicals are still having a large role. Why was gas not dropped in World War II? Because Germany thought we had gas as well. We actually didn't have apocalypse level gas like they did. Had they done it, they would have scored an advantage, no matter how evil it was. Okay, something else kind of happened here. Ship blew up. All the sailors that inhaled all the mustard gas, no bone marrow cells, no white blood cells. Beginning of chemo happened in that explosion. Strange, huh? Yeah. We'll end the chemistry story there. A little dark already. Yay! All right. Guardian Angel Scout is back to visit you. She's still alive and kicking, so that's good. Yeah, she's going. 11 now. But yeah, this is a big class. So, like, what are we at right now? We're like 7:30 maybe? 10:15. Oh, we got extra 15 minutes now. What do we do in farm? Like 7 minutes or so? 8. I don't remember. I mean, yeah, because it's a trade-off. You want more time or do you want to get out faster? Why don't we at least start with, let's do like 6 minutes, okay? Very good. I like multiples of 5, sorry. Actually, strangely, some of the higher rated things, remember the little survey where I was like, what resources were helpful in genetics? The advice I do actually like, because I take it for granted to do stuff. So, cognitive research with teaching says, don't talk for too long, break it up with something. Hence, that's why we intersperse the fun, active things. See, it's good. Then I get told that I'm not teaching you enough, and then I'll just lecture more. I can talk for, we'll just keep going. Anyway, there's a reason behind all the madness. Cognitive research backs up the structure, hence, when I slow it down and I speed it up, hopefully we're hitting somewhere in here that attention is kept. 3 hours is a different challenge, though. This is technically a genetics right there. Hooray! So, we roll in. Farber says, instead of hospice care, let's try these combinations of things that I know kill blood cells. And this was the first time philosophically you had to ask. Treatment was not easy, by the way, but it was this or dying. So here we go. What is it worth? And like, even we'll get into the future stuff that we're doing in the last 2 years where like years are being added right now. But like, what would you give for more months? Anybody ever read For Whom the Bell Tolls? And the central message is that the dude knows he's going to die and he has to live a life in 2 days. Months can be a life to a lot of patients. That's a Christmas, that's a birthday, that's a grandchild, I don't know, anything. It means little as we look at the numbers sometimes. But look at where we've come in those periods and look where a lot of this shot up to. That giant leap right there. There we go. I'll tell you right now, here's our initial like kind of mustard gas type stuff. Here is where we start building the regimens. So the survival curve with all these people on here, this is built on chemo. We see radiation, see it work. We do get better at surgery. Start to measure things properly, not Wild West. A key thing that we found out is, this is a strange thing, it wasn't another ingredient, but we found ways to sort of facilitate inhuman doses that could eliminate all white blood cells, all bone marrow, clean. So there were procedures that we learned in here that made, again, lethal chemo combos standable. So even though this is a huge jump, none of these are fun. Okay, not in the slightest. We've gotten a lot better at managing side effects, but remember the area that we're in. It doesn't matter if the patient's alive. That's the philosophy right now. Is that what you believe as healthcare-ish people? That massive pain every day, bones breaking because they're weak from the radiation. There's crisis on every side, right? So when the day comes that you maybe are explaining something to a patient, acknowledge that the cure and the treatment can sometimes, in some cases, be as bad. We'll talk later about the H-word, hope, and how powerful it can be, but how tough it can also get. So, VAMP is our first set of chemo drugs. And guess what? Here's a strange thing. We're still in that, we don't know why. We don't know why these work, but they do. We're going to zoom in on the targets as we go and like we see, because there's finally a shift in the 80s where we search why it's working. We discover the mitotic cycle and what we're actually killing with these things. We don't know that yet. We don't know that each of these is destroying that mitosis cycle. And there's a reason. Why do you think all the side effects in chemo are where they are? The hair, the skin, the intestine. What do they kill? Cells that grow, right? That's why you see those. Now, Lee was overambitious, and he got fired for a couple places to do this. Here he comes with the first way that you can actually survive VAMP. One of those is enough. You go in, you suck out some of your bone marrow from your spine, you punish the body with VAMP, you kill everything, and you put it back in. You transplant the bone marrow cells, and they hopefully regrow cancer-free-ish. Yeah. And you see that little quote down at the bottom. We didn't have a good system for blood typing and blood transfusions, so bucket out, bucket in, right? Hospitals are still a little bit of a dirty place at this point. So that was our first solution. We found things that work. We don't know why. Let's do more. And to make it clear, plenty of people did not survive the transplant process either. Here we go. Kaplan-Meier survival curves. Another semi-familiar name, perhaps. Curie's work showed that the anemia not only worked, but it would just kill most cells that it was near the radiation. That is the original radiation. X-rays weren't big enough. Those are rods of radium that would be surgically inserted. Targeted applications of today for radiation are a little more fine-tuned. They're in the middle here. I think proton beam is one of those 4. But there are plenty of ways that we can still use radioactive material and insert it near the tumor, and it will blast. That's its job. Now, radiation is indiscriminate, but remember what I said about strengths being weaknesses, right? How many mutations does a cancer cell have? Lots or few or 0, right? We're up there, right? No matter how much I talk a tumor cell up, too many mutations is just too damn many. Radiation can be survived by your nice healthy cells at the right dose, but the push you give the tumor cells, there's too many wrong genes right now. We can't survive this in a lot of cases, not everyone. Because you know most of the time this thing's coming back worse, right? The resistance, that one type of stuff. So radiation does add not only a broad tool, but a very targeted one, as you can tell. Red text, but I'm regretting it a little bit. Also, you have the key info, but I would say the key red here that you need is what cells die that need to grow and do mitosis. Every one of these symptoms, and this is a Cancer Bio 400, so I do want you to know what happens with chemo. Somebody asks you. Take a look at the little cartoons. What systems do they mostly affect? Yep. One more gets tougher too. Have you ever asked yourself why tumor patients can't have vaccines? They don't work as well. Killed your white blood cells, man. B-cell people that I study lymphomas, you can't have any vaccines. Killed your B cells because they were a tumor. So, again, focus on the easy ones over here. I wanted to include something very comprehensive because I enjoy that. As an exam question, it would be something more along the lines of like, what are 5 prominent symptoms of high chemo, right? You can choose your own adventure in that case. And yeah, all the stuff you're going to do in here, it's going to mash up your brain, and that's going to be tough because big connection between the brain is actually your immune system. If you give them a push or a pull, it'll go a little bit. All the genes associated with schizophrenia, they're immune genes. Strange, huh? But yeah, mostly I would say I would rank it, like you said, gastrointestinal, moving up and down and through the system. So another advance that this led to is, remember where we started in the 50s, and now we're at least doing chemo. Done a lot better at keeping patients happier. Well, maybe that's not the right word, but palliative care did not really exist outside, like I said, here's some liquor. I don't know. So some of those symptoms you saw, they were a big reasons why we invented anti-nausea, right? Big ones, we invented pain pills, right? Not that opium wasn't floating around at this point. What other stuff do we see on here? I know it's blue text. Oh, beginning. I'll zoom in on this. Beginning of a couple things that, again, are repurposed now. Depression, the anxiety in patients. That was the start. Some of these. The start of some of the, not antipsychotics, but the antidepressants, the serotonin uptake inhibitors, some of those. Equally, this was an area that we started to master heart drugs because the heart would go through quite a bit. But obviously, where there is an audience, there is a drug company in America, especially in the 70s, as they started to figure this out. To this day, we are somewhat haunted by pain, right? What was the drug that was all nasty when I was a kid, like 2010s? What was the bad drug back then? Like cocaine, marijuana?
No, that's.
Not yet. Now, there's now coming to that, yeah. Pain pills were still tough. I'm trying to remember, yeah. Like abusing, like sniffing the Sharpies, that doesn't count. Drinking, I'd say, obviously, like, but now what's the thing? Fentanyl, yeah. What is fentanyl made for? Yeah. And the 2 unit farm, no wife fent is so good at its job. There are distinct classes of pain receptor, and it stops all 3 in the spine, in the periphery, and in the brain. And it's really strong. Why'd we invent this thing then? If it's addictive and you're going to die from the addiction. Remember those tumors that we saw, like blowing through all the tissue? We'll see a couple of pictures of it. I actually think in genetics we saw the picture where a tumor metastasized into the bone and it breaks the bone. You either amputate or live in terrible pain for as long as you can make it. Fentanyl is a hospice drug. And knowing how powerful that drug is, yeah, I don't know how many of you have been in a hospice situation, but it's tough. It's a good experience for medicine, to say the least. All right. I actually am like way ahead of schedule. You guys want to see some, you okay with going a little further? Let's do it. Okay. I don't have any changes. Stat. All right. So here we are in this age of mass chemo, mass everything. But we keep this isn't on the test type of slide, but again, this is sort of a timeline we're building. We're in a very tough place right now because all they did was say more radiation, more surgery, more chemo. And nobody was coordinated, nobody was doing stats, nobody was working together. There were 2 facets that were not working together super bad. The physicians were never communicating with the scientists. Matt.
This is a new PowerPoint.
Yeah, oh yeah, no key info. Sorry, we're skipping ahead. I got a little ahead. You'll get it next week, don't worry. Sorry, yeah. You guys will survive. Remember when I snatched your slides away in genetics because I'm angry with you? Everybody laughs so hard. It's ridiculous. Yeah, it's okay. That was pretty good. I wanted you to do better. Sorry. Yeah, John lost. He's like, where are my slides? It was fine. We survived. So we'll go slower here. We'll get a little ahead. That's it. Like I said, first time doing the class, I'm always a little like, how far am I going to get today? So we got a lot farther than I thought. You guys are good. So, till the 80s, and we'll see what happens in the 80s that kickstarts things back in the right direction. Basically, from all the good stuff we found, we just kept doing more of it. And we weren't treating it why. No physicians communicated with scientists. We knew what chromosomes were. We knew what DNA was at this point, and nobody was communicating what was happening to that stuff. This is a question that is very hard to appreciate because we know in this room. But again, tumors would pop up and we didn't even know what they were. We didn't know what caused it. We didn't know about smoking yet. Here's the first thing that we thought caused tumors. And it does rarely. Not all the time. Chicken virus. There we go. We found out pretty quick these chickens had like tumors on them. And again, mega industry, mega study. Chickens, agriculture, money. Why are my chickens dying? These tumors. So they could take the tumors from the chickens and put them on mice, and you could get a tumor to grow. So here comes a tough period in cancer history as well. This is successfully showing that RSV can cause types of cancers. Perfect. From that point on, everybody's like, it's a virus. The whole thing, it's a virus. To this day, there are cancers that get caused by viruses. We'll see the details. It's nasty and it's crazy. It's the rare case, but we cling to what we know. We were starting to understand viruses quite well at this point, and so we said, that's the answer. So we'll see the details why, but y'all remember from genetics, viruses bounce, cut, paste, move, right? That's not good for genes in a lot of cases. And we'll see exactly a gene called SERC was picked up by this virus by chance. Remember translocations? Gene goes to the wrong spot. The virus actually picks that gene up and takes it with it, becomes a better virus. It causes its host to grow more, host cells, right? Evolution at work, nasty stuff. Another miscommunication. So we have two primary cancers that can be said to be hormone driven. Prostate, breast in some cases. No testosterone, prostate shrinks. Makes enough sense. It was basic science it was kind of looking at. Nobody talked or put this together. We were still chemoing prostate. We were still surgerying prostate. What could you do if you would put together that this physiological system is addicted to that hormone? We can stop that hormone from showing up. The tumor that is addicted in this spot of the body, testosterone in this case, will shrink, die. This is also a good anti-ad against all the testosterone supplements you see advertised too. Please do not mess with your hormones. And you're like for weightlifting and beefcake time, right? He would later apply this elsewhere. There is another often hormone-addicted cancer. Breast cells still have the pathways to rely on estrogen. Should you deny them that, tumors would shrink. Now, this was a great advance. But does every breast cancer fully rely on the estrogen as its growth and proliferation signaler? No. Who's heard of triple negative breast cancer? That's the bad one, right? One of the negatives is estrogen. If you have estrogen positive breast cancer, tamoxifen, block. Pretty good prognosis. But every tumor has strengths and weaknesses. Remember, your cells have these pathways right here. They're supposed to grow. Those are the old development signals. It's all natural. It's just being corrupted. Sorry, I promise I'm not so dull. I'm just trying to go slow. I know we don't have the slides. Look how good this is. Everybody's like focused and stuff. Not yet, not yet. So the other beauty of this that was not communicated, because we still hadn't asked why, is that we still hadn't figured out cancer cells they're us, just more. And they can push ours out of the way. They eat more and they're bigger and they're angrier. But like I said, the estrogen treatment was excellent for those tumors that were staying positive or being estrogen addicted with the receptor. Should the tumor be relying on other growth pathways which do exist, no response. Doesn't care that you denied estrogen, it's getting its signals somewhere else. And I have it in the text down there, but again, everybody thought that every breast cancer was the same thing. Clone. That's where we were at still. Even though we had started staining, we had started doing antibodies a little bit, we could have had the tools to save a lot of lives, but egos get in the way of a lot of progress sometimes. It's tough. So, like I say at the bottom. This was tough. There was a period in the 80s. What happens to the cancer proportional deaths? It went up. That's not fair. We did all that work. And we do have stuff that can treat it. Where was the emphasis wrong? Y'all had it right on your timeline. What happens here? What happens more and then here? There it comes. The mistake is that we were focused on treating the disease, not preventing it. And again, it's so hard to think about, but nobody thought smoking was killing. Nobody thought DDT and insecticide was killing the eagles, or us, by the way. I'll do a little skull and crossbones here. Oh, that crossed over. Anyway, scary. So this was frustrating, and this frustration caused a lot of chaos. Chemo people pointed at the surgery people, the radiation people pointed at everybody, and everybody said they were wrong. For literally 30 years wandering in the desert, not to make another like historical reference, but nothing, no communication. Remember what I said at the beginning of class, communication solves all these problems? Dang it. We even in this point, we'll meet this in more detail later, cisplatin, one of our best chemos, attaches directly to DNA, kills the S phase, destroys DNA replication. It didn't stop this. We were seeing months being gained by patients, years because of cisplatin, and nothing stopped it. That shows you how powerful that curve was. We'll do a couple more fun things, but then we'll leave some history for the next round. Okay, because I do think I want to finish the cause idea. Smoking, obviously. But again, we're stuck on viruses in the 50s at this point. Literally nothing else. We're not even on to genetics. We don't even know that yet. We know heredity exists, but it's rough. We don't know a lot of stuff at this point. So heredity and environment are not even talked about yet. And again, the other tough thing with being a cancer patient back in the day is it was very scourge-like for whatever reason. So speaking of World War II, when the bombs went off and everybody got cancer later, they were treated like soulless, basically, that they had died already, basically. Things have changed, luckily, and that's a big part of the public health war, not cancer, that actually worked. Here we go, though. We'll zoom in a little bit. Can you imagine sweeping ash all day? Who knows what they were burning, by the way, back then? Oof. All day, every day, just going. Now, they figure out all the way back in 1760, why do the chimney sweepers keep getting, this sucks, they keep getting scrotal cancer? And remember, where are we at with anesthesia at this point? So, regardless, this guy does figure out, just out of intuition, like, I think the soot is bad. I think it's rough. Maybe it caused the disease. But of course, he can't do a trial. He can only look back in time. We have harnessed math and stats now. We have our own carcinogen classifications. Go down. This is read to a degree. You don't need to know every single one. 200 cancer bioclass, and most people are pretty curious about this regardless. So, group 1 substance. Technically, maybe it does something, but the testing is very either positive or nothing. 3 moves up. We technically are talking and saying like kind of conflicting evidence, inadequate, but there were a couple times things were weird. So maybe don't, eat a bunch of fluorescent lighting. But as you can tell, like we're still sort of in like, I think it's gonna be fine land. Start to get to it's like gas, fumes, some other like kind of crunchy Colorado hippie stuff, but I'm not gonna touch that. That possibly begins to creep up in here. And again, I'm gonna guess that if you used aloe vera every day, your chances are still pretty fine of not causing a cancer from that. But it does give us a good statistical look. What is aloe vera treating usually? Sunburn food crop. All right, here we go. Probably. We've moved up to probably. Emissions. Steroids. Good old red meat. Ooh, you see that one? Don't work night shifts. Your circadian genes are waiting for a clock. And if they are denied that, things go a little dark with your immune system in your brain and other places. They need to be renewed. As somebody who did work a night shift for a year and thought it was great because of the overtime and the money, I do remember like hallucinating when I was playing Skyrim, but we're good now. Maybe that was the concussions too. I played football back in the day. Now let's do this one. We know that even some are small. And here's a good designation for class 1. Something can be carcinogenic. It can statistically put you in a further group. Bacon, processed meats. We did the test like 2 years ago. Sorry. Yeah, especially when you burn it. Booze. Not ideal. However, alcohol, no. I'm not gonna get that, but I'm talking like the risk is usually measured in trials when it's like, who's ever looked up at what an alcoholic really drinks? Yeah, I'm talking like, you look at the forums, I remember looking at one and I was like, it was like, okay, before noon, I will have only had 7 shots. At 3, I will have only had 10. By bedtime, it was only 19, and we're gonna tone down. That's my tone down. I'm not joking, that's tough. That's the kind of damage that you're talking about. It's injury and repair. Injury and repair. What happens when you repair your tissue? 1 cell becomes 2, right? Now, the big one. Here is the other thing. And I know a lot of you like got mad when it was like pork is bad. Pork classifies as a type 1. You have about a relative risk of like 2% more maybe likelihood, or maybe with alcohol. Tobacco is more like 28% more likely. So even though they're the same category, one is far worse than the others, to say the least. We could technically make like a group 0, like a mega group, I suppose, but Gotta confuse people. So that's where we're at with causes and et cetera. You want to save SIGs for next week? Got a little activity for us before that. We can do cigarettes now. But I think SIGs would be a good jumping off point because they are kind of their own story. And when the original, this is one of my favorite stories with the law, with patents, stats, courts and stuff. It took years and mountains. And this was what sort of united a lot of science was like, SIGs are bad. Shown it. Okay, we'll get into that next week. In the meantime, where's my slide for this? I had one. Yeah. Don't worry, discard. Dun da 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 da. Oh, you're in a foreign level class. We actually have to do this. Technically, it doesn't count for anything. Don't worry. But do try, please. You don't want to be like embarrassed. I'm fine with it. All right. So, do your best. It's actually 20 questions. I know, do your best. I mean, you don't want to fit in 50 candidates. That's all right. You'll notice that the questions you see in the first half are more like they're kind of prepping you for what is to come. When you get to question 11 through 20, I am asking you things that I will expect by the end. So I don't expect most of you to know 11 through 20. But at the end of the class, we'll do it again and we'll see. Oops. That's the idea. All right. I told you I have to intersperse lecture with active learning. Test is active learning, right? Here we go. Don't work together. Challenge yourself. There you go. 1, 2, 3. Nice. 1, 2. You do one for fun, remember?
Yeah.
You do one, remember? Left it out. Okay. 2.
I'm so excited for you.
Do you have a good time before this?
Right now.
Like in the previous 30 minutes.
Oh, yeah.
Good.
No, I'm not.
We have to do these in 400 things.
No, you don't. You just want in cardio.
Plus, you know, it's not the worst preview of what my questions look like sometimes. Barely enough.
So
I don't know why it's printed wrong. We got one extra. Oh, good. Who's got an extra one? Right, because the class like shifted this week for people. I'm gonna print one now. We'll be good. I've waited for this. You didn't take me in genetics, so now it's time. I'll leave that out. I gotta stop recording. I shouldn't have put that.